Well, we've got a fun one tonight. We're going to focus on some probability rules. We're going to start here with a nice example in exercise 1. A credit card company states that 42% of its customers are classified as long-term cardholders. 35% pay their bills in full each month, and 23% are long-term cardholders who also pay their bills in full each month. Let the event that a randomly selected customer is a long-term cardholder be L, so that's key, and the event that a randomly selected customer pays his bill in full each month is F. What are the values of the following? So the probability of L, and if we recall, L is the probability that a customer is a long-term cardholder. I would say, looking back, that that's 42%, so we could call that 0.42. The probability of F, and again, looking back, F represents that a selected customer pays his bills in full each month. That was a probability of 35%, or 0.35. And the probability that they're a long-term cardholder and pay their bills in full is represented by 23%, or 0.23. Remember, this is the intersection, or the notation for and. Part B says draw a Venn diagram and label with the probabilities. So we practiced this yesterday, and hopefully you're feeling pretty good about it. Remember, we're going to have two circles in this case because our two different events are L, that we're a long-term cardholder, and F, that we pay our bills in full. And we'll box that in to represent the entire population. And what do we know for sure? We know that 42%, so I'm just going to put my arrow over here, 0.42 for circle L. I know circle F, we just stated here, is 0.35. And I know P, the probability of L and F, so where L and F meet, the and section, is 0.23. So now I can easily calculate these other probabilities. Remember, the rest of L is going to be 0.42 minus 0.23. So there I would say I get 0.19. For the rest of the circle, I'm going to say that's 0.35 minus the 0.23 that's already in there, for a total of 0.12. So remember, don't forget you're going to have people that are outside here. All of these probabilities, these three numbers and this guy out here, have to total 1. So I'm just going to say that's 1 minus 0.19 minus 0.23 minus 0.12. And that gets me a total of 0.46. So just to be clear what this talks about, this is the probability that you're a long-term cardholder, the probability that you pay your bill in full. This is the probability of being both a long-term cardholder and you pay your bill in full. And this represents that you're not a long-term cardholder and you do not pay your bill in full. Part C says use conditional probability to calculate the formula, the probability of L given F. Now, we haven't talked about this notation before, so we do want to show it to you. Another way to say given is a vertical line. So we could say, I just want to be clear, that this is also the probability of L given F. And you might probably need to make a note in your book here that this vertical line is just another way to say given. So the probability of L given F. So I'm going to start by identifying my given. My given is the F circle. So I would say that has a total probability, if I add those together, of 0.35. And I'm strictly looking in that circle because that is the given circle. What is the probability of being an L in this given circle? Well, the only L section in the circle is right there, so I would say this probability is 0.23 divided by 0.35. And it does say round your answer to the nearest thousandth, so I'm going to go with 0.657. Part D says now use the conditional probability formula to calculate the probability of F given L. So again, let me just show you that notation, the probability of F given L. So again, in case they don't say the word given, that's what that vertical line means. So why don't you pause it, try that one on your own, and see if we agree. Good luck. So we'll see if you agree. I'm given the circle of L, so I know my probability is 0.42, and I want to be F in that circle, so I'm saying that is 0.23 out of 0.42. And to the nearest thousandth, I get 0.548. So which is greater, the probability of f given L or the probability of f? Well, let's go ahead and find out. The probability of f given L, we just said was 0.548. Now we need to compare that to the probability of just f. So the probability that I'm in circle f, well, is that total circle, so that's 0.35 divided by the entire circle, which of course is just, or the entire sample space, which of course is 1. So that's just 0.35. Part F says, remember that two events A and B are said to be independent if the probability of A given B equals the probability of A. And that's what we just showed here. The probability of F given L, does that equal the probability of F? So the question is, are those two events, F and L, independent? And I would say definitely no, they are not. The probability of F given L did not equal just the probability of F. Now remember, you could have gone about this another way. That was only one option. You could have said the probability of L given F and show that either does or does not equal the probability of just L. But either way, we talked about independence 2 days ago. Remember, this probability needs to be the exact same. Okay, here it is, one of our first big probability rules. The multiplication rule for, and this is big, independent events. Okay, and here's the rule. The probability of A and B is equal to the probability of A times the probability of B. So here's what I want you to box in. This and means to multiply. But this only works, I can't stress enough, let's start this, if the events are independent. If one event does not affect the other one from occurring. Independent events. So our key is that when we see and, we're going to multiply as long as these events are independent. So here's our first example. A number cube has faces numbered 1 through 6, and a coin has two heads, heads and tails. The number cube will be rolled, and then the coin will be flipped. So the question is, are those two events independent? If I were to roll a cube and flip a coin, does the result of the coin have anything to do with the cube? No, they're two totally different physical objects. They are independent of each other. So this probability rule is allowed to be used because they are independent. So now let's answer this question. Find the probability that the cube shows a 4 and the coin lands heads up. Again, I want you to box that word in and. Okay, that's telling me since they're independent, I am allowed to multiply these two events together. So the probability that the cube shows a 4, we'll picture a cube, numbered 1 through 6, how many 4s are going to be on there? Well, 1 out of the 6 sides, and means to multiply. Now you have a coin that lands on heads. How many ways can a coin land on heads? Well, there's 1 heads out of the 2 sides to the coin. So I would say that probability is 1 out of 12. The second question. If you toss the coin 5 times, what is the probability that you will see a head on all 5 tosses? So are these events independent? If I toss a coin once, does that have any dependency on what the next outcome is going to be if I toss the coin again? Of course not. So because this is independent, if I toss the coin the first time and I get a head, the probability is 1/2. And if I toss it a second time, the probability I get a head is 1/2. And a third time, and a fourth time, and a fifth time. Do you notice how it's an and? It's not or. It's not this one or this one. It's I'm going to get a heads and a head and a head and a head and a head. So I'm allowed to multiply, and I get 1 out of 32. So if we were to do this, toss this coin 5 times and got heads every single time, would you think that the coin is a fair coin? Why or why not? I'm thinking most likely not. Go ahead and take a quarter and flip it 5 times. Do you get a heads every single time? Probably not. Could it happen? Sure. Is it probably going to happen? Probably not. So I would suspect that this coin is perhaps weighted, that it's happening, that we're repeating with that heads every time. If you roll a number cube 3 times, what is the probability that it will show a 4 on all 3 throws? Okay, well, that means I want a 4 on the first try, and a 4 on the second try, and a 4 on the third try. And again, these are all independent. Whatever I roll on the first try has nothing to do with the outcome of the second try. So I can get a 4 1 out of 6 ways, and then I'll roll it again, and I can still get a 4 1 out of 6 ways, and 1 out of 6 ways on the third try. So I would say that's 1 times 1 times 1 is 1, 6 times 6 times 6, 216, or approximately 0.005. So again, if you rolled the cube 3 times and got a 4 all 3 times, would you think this is a fair cube? Again, probably not. You can go ahead and roll a dice yourself. Do you get the same number every time you roll it? Odds are that there's some sort of weight to it. Exercise 2. A spinner has a pointer, and when the pointer is spun, the probability that it stops in a red section is 0.25. If the pointer is spun twice, what is the probability that it will stop in the red section on both occasions? So, what type of question are they asking me? I want to stop on red the first time, and I want to stop on red the second time. Do you see how they didn't say and? You have to interpret that from the question. I want red on the first one and red on the second one. Well, are they independent? If I spin the spinner once, does that have anything to do with this when I spin it a second time? Will that first spin affect the second? No, so they are independent events. So I'd say that's 0.25 times 0.25. Which is 0.0625. B. If the pointer is spun 4 times, what is the probability that it will stop in red on all 4 goodness gracious, on all 4 occasions? So again, I want a red, and a red, and a red, and a red. Okay, so I'm just writing an and for myself because I know I want red, and red, and red, and red. So because they're independent again, I can go ahead and multiply 0.25 times 0.25 times 0.25 times 0.25. 0.004. If the spinner is spun 5 times, what is the probability that it never stops on red? So on my first spin, I don't want red. What's the probability that happens? Well, if it happens 0.25, then it doesn't happen 0.75. Remember, our probability is out of 1. So that's my first spin and the second spin, so times, and the third spin, and the fourth spin, and the fifth spin. So 0.75, 0.75, 0.75, 0.75, for a total of 0.237. Okay, so our first big rule says if the 2 events are independent, we can just take their probabilities and multiply. When a car is brought to a repair shop for service, the probability that it will need the transmission fluid replaced is 0.38. The probability that it will need the brake pads replaced is 0.28, and the probability that it will need both transmission fluid and brake pads is 0.16. Let the event that the car needs transmission fluid be T, and the event that a car needs the brake pads be B. What are the values of the following probabilities? So notice they're not going to tell you to set up a Venn diagram each time. Your gut instinct needs to be, I'm talking about these 2 events, let's be smart enough to draw this out. Alright, so I'm going to let you pause it, fill the Venn diagram in. You should be able to get each circle in this outside piece. So good luck, pause it, and then turn it back on. So hopefully yours looks like mine. Again, I knew this whole circle, I knew this whole circle, and I knew the and section. I subtracted to get my 0.22, subtracted to get my 0.12, and then I know these 3 numbers and this number have to total 1. So the probability that I'm in circle T, so that's the whole circle T, I would say is 0.38. The probability of circle B, the whole circle, is 0.28. And the probability of T and B will have to be in this circle and in this circle at the same time. So just 0.16. So here it is, box it in. This is our second big rule for probability. The probability rule for addition. The probability of A or B is equal to the probability of A, the first event, plus the probability of B, the second event, minus the probability of both A and B. So yes, we have to memorize this. Now, none of this is given to us. So one big thing we can take away is that OR means you add, where AND meant we multiplied if they were independent, OR means we're going to add. But now we also have this extra little piece in here. We have to subtract out anything that basically repeats in both. And I'll show you what I mean. So back to that previous question, it says use the addition rule to find the probability that a randomly selected car needs transmission fluid or brake pads replaced. So first of all, let's write our notation. I need the probability that I need transmission fluid or brake pads. We talked about the union the other day representing OR. So the rule is the probability of the first term, so it's the probability of transmission fluid, OR means to add, the probability of brake fluid, but now I have to subtract out anything that repeats, the probability of both, T and B. So, hopefully pretty simple. The probability that I need transmission fluid is this whole circle, which we said was 0.38. Plus the probability that I need brake pads, which is this whole circle, which we said was 0.28. Now I have to take out anybody that repeats. So do you see what I mean by repeats? By me saying 0.38, I'm including 0.22 and 0.16. By me saying 0.28, I'm again including 0.16 and 0.12. Do you see how I use 0.16 twice? So I have to take out the AND section, the part that's in T and in B, that 0.16. I now have to subtract that out. So I would say that is a total probability of 0.5. Okay, so the probability that I'm in this section or this section is the probability that I'm in here plus the probability that I'm in here minus anybody that repeats itself. So that 0.16 was in both. I have to take it out. All right, Josie will soon be taking exams in math and Spanish. She estimates that the probability that she will pass the math exam is 0.9 and the probability that she will pass the Spanish exam is 0.8. She is also willing to assume that the results of the two exams are independent of each other. Assuming Josie's assumption of independence, calculate the probability that she passes both exams. Okay, so now we have to put it into our own lingo. What does it mean to pass both exams? I'm saying that's the probability I pass math and the probability that I pass Spanish, or Josie passes both. So she's going to pass math and she's going to pass Spanish. Now, assuming that they're independent, the rule says I can just take them and multiply. So I would say that's 0.9 times 0.8 for a total of 0.72. So again, and means I'm going to multiply as long as they are independent events. Part B, find the probability that Josie passes at least one of her exams. Hint, passing at least one exam is either passing math or passing Spanish. So I want to pass math or Spanish. So or means I'm going to add, so it's the probability I pass math plus the probability I pass Spanish minus the probability I pass both math and Spanish. Okay, so hopefully that or sounds familiar. I'm going to add the first one, I'm going to add the second one, but then I have to repeat anybody that's in both. So anybody that's in math and Spanish. So the probability that I passed math, or Josie passes math, was 0.9. Plus the probability that she passes Spanish is 0.8. But now I have to take out the probability that she passes math and Spanish. And guess what you just found right here? The probability that she passes math and Spanish. So now I have to subtract 0.72. So that probability is 0.98. So there's a very high chance that Josie's going to pass at least one of these exams. All right, we have a set of 40 cards consisting of the following. We have 10 black cards showing squares, 10 black cards showing circles, 10 red cards showing X's and 10 red cards showing diamonds. A card's going to be selected at random. Find the probability, so here's my P, that a card is black or shows a diamond. So I'm going to say black or diamond. So or in my head right away is registering that I have to add, but then I have to subtract out the probability of both. So I'm going to write out my formula. It's the probability of B, in this case, plus the probability of D. So I'm going to add my probabilities, but now I have to subtract the probability of B and D. Okay, so just remind yourself, it's the first term plus the second term minus the probability of both. Okay, so what's the probability that you select a black card? Well, it looks like there are 20 black cards out of a total of 40. What's the probability that you select a diamond? I would say there are 10 diamonds out of the 40. Minus, you are black and a diamond. How many cards are black and a diamond? Well, I would say none, so minus 0. So I'm going to kill those zeros and kill those zeros. I have 2/4 plus 1/4 for a total of 3/4. In our next example, we're going to combine both the multiplication and addition rules. So here we have a red cube labeled 1 through 6 and a blue cube labeled in the same way. The two cubes are rolled. Find the probability of each event. So it says both cubes are 6s. Okay, now notice it didn't say and or, so we've got to be smart enough to put it in our own lingo. If both cubes are 6s, I'm saying that's the probability that the red has a 6 and the probability that the blue shows a 6. Okay, notice both means the word and. So the probability of and, as long as they are independent events, means I can take the probability of a red 6 times the probability of a blue 6, as long as they are independent. Well, does the red cube affect the outcome of the blue cube? Of course not, so they are independent. So the probability that I see a 6 is 1 out of 6 times 1 out of 6 for a total of 1 out of 36. Okay, a little trickier now. The probability that the total score is at least 11. All right, so we got to think about this one. How do you get a score of 11 if you have dies, two cubes numbered 1 through 6? So I'm thinking the first thing I could get is I could get a 5 and a 6, or I could get a 6 and a 5. That's at least 11. Or I could get a 6 and a 6. Is there any other possible combination that scores at least 11? I don't think so. Okay, so let's write this out in English. I could get the probability of the red being a 5 and the blue being a 6, or I could get the probability of the red being a 6 and the blue being a 5, or I could get the probability of the red being a 6 and the blue being a 6. Do you see how from this little detail here, we've got an and an or in here? Okay, so let's go through and think about this. Let's start with this first one. The probability that I get a red 5, so I would say that's 1, 6, and means to multiply. A blue 6 would be 1, 6, or means I'm going to add. The probability of a red 6 would be 1, 6, and means to multiply. A 1, 6, or the probability of a red 6 and the probability of a blue 6. So I would say that's 1 over 36 plus 1 over 36 plus 1 over 36 for a total of 3 out of 36, or 1/12. So again, they didn't use the words and or, but I had to interpret that and put it into my own sentence. All right, in a large community, 74% of the people are adults. 71% have traveled abroad, and 14 are neither adults nor have traveled abroad. So again, you're going to get the most out of these video lessons if you pause it and try it yourself. So you'll notice they don't say set up a Venn diagram, but we can clearly see we're talking about two events. So pause it and set up your own Venn diagram. Good luck. So maybe you're kind of stuck where I am at the moment. I had my adult section was 0.74, my traveled abroad was 0.71, and then this section here was 0.14. So here's what I'm going to do. I'm going to label this overlapping section as X. And I know that my total probability between this circle, and the outside has to total 1. So I'm going to write a silly little equation, or simple little equation, not silly. I know that 0.74, that circle, plus my other circle, 0.71, minus, so it's like an or. I could be in this circle or this circle, but then I have to subtract out anything that repeats or that's in both. So minus X plus the outside piece, 0.14, all have to total 1. So if I went too fast, let me say it again. I'm basically writing an or statement. This circle or this circle, so that's 0.74 plus 0.71, minus anybody that repeats, that's in both, so minus X, plus this 0.14 has to total 1. So if I add those together, I get 1.59 minus X has to equal 1. And I can subtract that over, so negative X has to equal negative 0.59, X has to equal 0.59. Which tells me that X, the probability that you're in both, is 0.59. Now you can easily go get the other pieces. I can simply do 0.71 minus 0.59 to get me a 0.12. And I can do 0.74 minus 0.59 to get me a 0.15 here. And how can you double check yourself? Well, remember, this number plus this number plus this number plus this number all have to total 1. So now once that's complete, A, what is the probability that a person is an adult or has traveled abroad? So I'm going to write it out in notation. The probability I'm an adult or traveled abroad is the probability of the adult plus the probability of traveled abroad minus the probability of both, A and B. Now I did use T up there, so I'm just going to replace this with T's maybe to help us out a little bit. So the probability that I'm an adult is 0.74, plus the probability I traveled abroad is 0.71, minus the probability I'm in both is 0.59. And I get a total of 0.86. B, what is the probability that a person is an adult and traveled abroad? So you would have to be in this circle and in this circle at the same time, simultaneously. So I would say that's just 0.59. And C, assuming the events are independent, what is the probability that a person is an adult and has traveled abroad? Well, again, if they're independent, the probability of A and B is just the probability of A times the probability of B. So the probability of A was 0.74 times the probability of B, which is 0.71, which is a probability of 0.5254. So all in all, we've got two going on, our probability rules. We have the OR rule, which says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And we have the AND rule, which is only if the two events are independent. You can take the probability of A times the probability of B. Well, just like usual, we'll have some great practice in class tomorrow, and we'll see you then. Have a great night.